In this particular question, a charged particle after being accelerated through a potential difference V enters in a uniform magnetic field and moves in a circle of radius r. If V is double, the radius of circle will become. So this is a question that came in 2020. So let us draw the figure first. So assume that this is the figure. So what this figure says, this figure indicates that there is a charged particle. Let this be the charged particle which is present in a electric field where potential difference created is V. So V is the potential difference created over here in this particular region. This is a positively charged plate and this is a negatively charged plate, and in this particular region we are creating a electric field, and due to this electric field, this charged particle will move with some speed. It will start moving with some speed. So let it move. Let this be a positively charged particle, so it will move, start moving towards right. So as soon as it reaches at the end, so over here let the velocity be v. Clear? With this speed it starts entering a uniform magnetic field, let it be b. So so before entering, so what will be the velocity of this charged particle? So we know that when a charged particle, is accelerated through a potential difference v, then it will gain some kinetic energy. So what will be the value of that kinetic energy? So from there we can get that kinetic energy k will be equal to q into v. Clear? So we know that the value of kinetic energy is half mv square in terms of mass and velocity it is. Then finally it will be q into v. So the value of v can be written as 2qv divided by m root. So this is the velocity, but as soon as it starts entering the uniform magnetic field, so then there will be a force upon this charged particle due to the magnetic field, and whatever the direction of that force, the direction of that force will be the force is given by F equal to q into v cross b. So we can apply the rule of cross product. So move your fingers from velocity towards magnetic field from the first vector to second vector, then thumb will give us the direction of force. So the thumb is pointing towards up. So this is the magnetic force. So due to this magnetic force, what will happen? It is saying that it moves in a circle of radius r. So it will start moving. It will just let the velocity be very high so that it starts moving. So the radius, let it be. It moves in a circular path. Let it moves in a circular path like this. So this is the circular path, and radius of the circular path, let it be r. So we know that as it moves in a circular path of radius r, then centripetal force will be provided by the force due to magnetic field, and from there we can write the relationship with that F equal to q b b q b cross b. That will be equal to nothing but this is the force, and this will provide the necessary centripetal force, that will be nothing but mv square by r. Okay, so upon equating both, we'll get the radius relation as r is equal to mv upon qb. So in this particular relation, if we put the value of velocity over here, so how much we'll get? So we'll get r equal to m upon qb into v is nothing but under root 2 qv by m. Clear? So that means it will be something like 1 upon qb 2 qmv. So under root 2 qmv. So this is the this is the radius of the given charged particle, but it accelerated through a potential difference v, and it enters in a region of magnetic field b. Okay, fine. Next is that what it is saying, if v is double, if the potential is double, then what about the radius? Here what will be the radius? So here in this particular case, let the potential difference v prime becomes twice of v. Clear? Then what about the new radius? So the new radius can be written in terms of this one as 1 upon it will be 1 upon q into b, 1 upon q into b, q into b under root 2 q m v prime. Here, so if we put all these values over here, 1 upon q v, 2 q m into 2q into 2v. under this one. So finally, how much will be getting? So 1 upon QB. So it will be, let the value of root, will take it outside. So it will be 2QM. So finally, how much will be getting? So root 2 times 1 upon QB 2QM A prime. So but this value is nothing but root 2 times R. So this is the actual value of R. So finally, new radius will become root 2 times R, original radius. So finally, check the option over here, root 2 times R. So option B will be the correct one.